So what we need to do next is we need to define and classify variables. So in algebra, when we think about a variable is like a symbol, usually a letter like X or Y or Z or something like that, that's representing or taking the place of a number. So it's not exactly the same thing when we're talking about statistics. It's similar idea, but in statistics, a variable is a characteristic of an individual who's a part of the population. So a variable can be lots of things. If you think of yourself as the population, you have lots of variables. One variable would be age. One variable would be gender. One variable would be what year you are in college. One variable would be what hometown you live in. One variable would be how many credit hours you're taking, and so on and so on and so on. Your annual income and the kind of car you're driving, and so on and so on and so on. There's all kinds of variables that we might be interested in about you or about the population. So variables, again, for statistics, are just characteristics of the individuals within the population. Now, there are really two main types of variables. There are qualitative variables and there are quantitative variables. Now, a qualitative variable is also sometimes called a categorical variable, and those variables allow for classification of individuals based on some attribute or characteristic. So basically, if we have a qualitative variable, basically what that means is we can categorize individuals by those qualities. So for example, like gender is a qualitative variable. We could classify individuals by whether they're male or female, and that's about it. I mean, we could find, like in the class, the percentage of males, the percentage of females, but with qualitative variables, you can't really do a lot of calculations. Pretty much all you can do is count them and like convert them to percentages, okay? Which in statistics, you'll see soon, we call percentages relative frequencies. A quantitative variable, on the other hand, provides numerical measures of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. So basically, if you can do some kind of a numerical calculation with the variable, then it's probably a quantitative variable. Now, so qualitative variables are generally not going to be numeric, but a quantitative variable will always be numeric. Now, I say a qualitative variable will typically be non-numeric. There are some instances where we would have a number that's still a qualitative variable. For example, like zip code. If we recorded your zip code, that is a qualitative variable that you can be categorized by your zip code, but it wouldn't make sense to do a calculation with your zip code. It wouldn't, like, you know, if one person's zip code is 62002 and another person's zip code is 62003, the fact that there's one difference there doesn't mean anything. Okay, so it doesn't make sense to calculate with zip codes. So quantitative variables will definitely be numeric. Qualitative variables will usually not be, but they can be. Now, if we have a quantitative variable will either be discrete or continuous. Now, I will tell you, here at the beginning of this course, we're going to work with both qualitative and quantitative variables. The further we go, the more we're going to deal mainly with quantitative variables. The reason for that is you can do more with quantitative variables than you can do with qualitative variables. So again, pretty much qualitative variables, the best you can do is categorize people or individuals. It doesn't have to be people, it could be items, objects, whatever. But that's about the only thing we can do, and then calculate frequencies and relative frequencies, which is like percentages. But with quantitative variables, we can do more calculations, like finding an average, for example. Okay, and there's meaning to those. So what we can do, though, depends on whether the quantitative variable is discrete or continuous. And so we want to talk about what that means. And again, this is important because it affects what we're able to do with the data that we obtain depending on if it's discrete or continuous. So a discrete variable is a quantitative variable that either has a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between two possible values, okay? So what on earth does that mean? So basically, if you think about how do you determine the quantity of a quantitative variable for an individual? If the answer is that you count, then it's a discrete variable. If the answer is that you have to measure it some other way, then it's not discrete, it would be a continuous variable. So I'm going to go ahead and read the definition for a continuous variable, and then we'll look at some examples. So a continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between two values. So, for example, if I were to be interested in the variable number of siblings, if you think about that variable, if I were to ask you how many siblings do you have, how would you determine the answer to that? You would count. It's possible that a person has 0 siblings. It's possible that a person has 1 sibling. It's possible that the person has 2, 3, 4, 5, 6, 10 siblings, and so on. So in order for me to determine the number of siblings, I count. Number of siblings is countable. That makes number of siblings a discrete variable. So it's quantitative and it's discrete. Now, on the other hand, if I asked, how much water did you consume yesterday? Now, how do you determine how much water you drank? Well, let's say tomorrow, so you could actually do it. How would you determine how much water you drink tomorrow? Would you count it? You don't really count water, right? You would have to measure it some way. Now, you might add like the contents of 1 bottle of water to the contents of a cup of water and so on, but you don't count the ounces of water, for example. You have to measure those. So the volume of water that you consume tomorrow is a continuous variable, not a discrete variable. Now that matters to us again, because as we go through this course, the way we handle discrete variables is a little different from how we handle continuous variables. Whether it's continuous or discrete affects our statistical methods. And so that's why it's important for us to pay attention to which we have. So again, the simplest way to determine is to think about, do you count or do you have to measure in some other way? If you count to determine the value that you're going to record, then that would be discrete. If you have to measure some other way, not count, then that would be continuous. Okay? So I have an example here that I want to look at with you. So classify each variable as qualitative or quantitative. So that's the first part. Is the variable qualitative or quantitative? If it's quantitative, determine whether the variable is discrete or continuous. So if it's qualitative, that's it. It's qualitative. If it's quantitative, then is it discrete or is it continuous? Okay. So hometown, I think I maybe blew that one because I think I already said that one before. Is that qualitative or quantitative? So this is qualitative. If I can spell it. Qualitative, that doesn't belong there. Again, how come? You can't really calculate with hometown. You can't average, say, Roxana with Jerseyville. You know, you can't calculate with them. The best you can do is categorize individuals by their hometown. And then again, you could possibly determine proportions or percentages, but that's about it. B, number of televisions in your home. Qualitative or quantitative? So we could find an average for that, right? So if all of you told me how many TVs you had in your home, we could calculate an average number of TVs. So that's quantitative. We can calculate with it. Now, since it's quantitative, is it discrete or is it continuous? And what makes it discrete? You count it, right? So how do you determine how many televisions are in your house? You would count them, okay? And that's what makes it discrete. C, the amount of soft drink consumed in a day. Qualitative or quantitative? Discrete or continuous? Again, you don't count the amount of soft drink that you consume. You would have to measure that some other way, like using a measuring cup or something like that. The amount of money in your checking account. Qualitative or quantitative? Discrete or continuous? Why discrete? So money's kind of tricky. How much money do you have in your checking account? You're going to have to count that. Or how much money is in your pocket right now? You would have to count that money. So that makes money, as a general rule, if we're talking about physical money, that would be discrete. Now, I do think there could be scenarios where money could be considered continuous, but it would have to be more theoretical in nature, where you could have like fractions of pennies and that kind of thing for that to be the case. So like physical money, like what you actually own, that's discrete. But if it's a theoretical, then maybe it could be continuous. Zip code, qualitative or quantitative? Even though it's numeric, it wouldn't make sense to calculate by a zip code. So the best you would do is categorize individuals by their zip code. The time to run 50 meters. Qualitative or quantitative? And is that discrete or continuous? Again, you're not going to count the time. You're going to have to use like a stopwatch or something like that in order to measure the time. When something's continuous, you could sort of change the degree of accuracy. So you might measure how long it takes you to run 50 meters. You might measure that to the nearest second. You might measure that to the nearest tenth of a second, to the nearest hundredth, to the nearest thousandth, and so on. So what you would record, you could actually change depending on your level of accuracy. Again, you can't really do that so much with like number of TVs, right? That, if you're going to be accurate at all, you're going to have it exact. With continuous, you can't ever really record it exact. There's always going to have to be a level of accuracy. Runs scored in a baseball game. Qualitative or quantitative? Discrete or continuous? Again, that would be countable. H, student ID number. So again, wouldn't make sense to calculate with the student ID number. So even though it's numeric, it's not something that you're going to calculate with, so that would make it qualitative. So the list of observations that a variable assumes is data. So it's information. So I could gather lots of data on you And those would be, again, the values or the observations that I record about you for the different variables. And so that is another definition of data. Now, there's really two types of data. There's qualitative data and there's quantitative data, which we've talked about before. We've talked about that previously. So qualitative data are observations corresponding to a qualitative variable, and quantitative data are observations corresponding to a quantitative variable, and discrete data are observations corresponding to a discrete variable, and continuous data are observations corresponding to a continuous variable. So we've talked about qualitative, quantitative, discrete, continuous in terms of a variable. Data is the same basic definitions. If it's countable, it's discrete. If it's not countable, it's continuous. If you can calculate with it, it's quantitative. If you can't calculate with it, it's qualitative. Again, that's the best you can do is categorize by that. And so when we look at a whole set of information that we've obtained, we're either going to have qualitative data, quantitative data, discrete data, or continuous data if it's quantitative. So again, that's just a technicality. The idea is the same as what we just did, but we're talking about the actual values that we've recorded. So that makes it data instead of just a variable at that point.